Yeah, good morning, students. So in last class, we have talked about total layers of OSI model, which consisting of application to physical layer. Functionalities of each and every layer we have discussed thoroughly. And finally, let me give a conclusion of all these layers. Application layer, which is always used to the user to interact with the computers, like user always make use of any kind of applications to get in, and then applications in turn talk with the next layer, that is presentation layer. In case of presentation layer, it is going to do compression, data translation, and these techniques which are very useful because nowadays applications work with one kind of data, whereas network standards is going to carry the data in different format. In that cases, it is going to transfer our data in a common intermediate form. That's the reason this presentation layer is required. And then after session layer, which is for authorization, authentication, and user dialog control, like uh, whether we are allowed to get the resources from the server or not, what are your user credentials, whether you are a authenticated user or not, and how long this connection is established between one system and another system. All these things are taken care by session layer. And later on we talk about transport layer. In case of transport layer, it is a process to process delivery model, like at host 1 we have one application. From that application we want to communicate with another application on host 2. Likewise, it is the process to process delivery model, which is existed at the source and destination. And then we have one more layer called network layer. In case of network layer, as we already know, our packets routing is a major task of the network layer. How our data packets are forwarded in the network, like which path it is going to use, and what are the different kinds of routing algorithms. All these things are covered by this network layer. Routing is a major concern, and one more major concern is addressing the systems. Addressing means which kind of addressing, logical addressing or physical addressing. So network layer always making use of this physical addressing. Network layer always making use of logical addresses, whereas MAC MAC addresses are considered in data link layer. So that is one more. And finally, data is reaching the physical medium, where our data message from the applications are converted into transmission medium form. Depends on the medium. The signals are generated, either light signals or zeros and ones, or like voltage signals, electrical signals. That depends on the transmission medium we use to carry our data from one system to another system. This way, all basic functionalities required for a data communication is well described and explained in this model, that OSI model, with a clear-cut cutoff of dividing the networks into a acceptable number. 7 is an acceptable number, where every layer is having a well-defined functionality. So now let us get into next slide. Yeah. So now let us talk about one more model, networking model. We call it as TCP/IP networking model. And TCP/IP is a real-time model which is implemented with the help of two major protocols, IP and TCP. And by using these two protocols, we can make use of networking, network routing with the help of IP protocol, and TCP for transmission control protocol. These two are the major protocols behind this TCP/IP model. And TCP/IP model is taking the references of all the layers which are existed in the OSI model. Now, if you observe this in TCP/IP model, it is not implementing all the layers which are specified in the OSI model. In OSI model, as we are having 7 layers, but if you come to this TCP/IP implementation, it is only talking about 4 layers actually. And later in the comparison process, we call it as a 5-layer model. 4 layers only existed. So here, presentation layer, session layer, these two are combined along with the application layer in case of TCP. So there is no session, there is no presentation layer in TCP, but it is part of the application. Nowadays, applications itself bother about which kind of data format we are going to process. All these things are application protocol dependent. Now all the functionalities what we have, like session layer functionalities, and then presentation layer functional. These functionalities are now coming along with the application layer protocols like HTTPS, FTP, SMTP. These all are application layer protocols. Now these two layers are already melt with this application, so that no need to present these two layers in TCP/IP model. And now when we come to transport layer, it is named as transport layer again in the TCP/IP model also. In case of TCP transport layer, we make use of three major protocols like TCP is one, UDP is another. If you are working with a connection oriented systems, the major protocol is TCP, which is a connection oriented reliable protocol, transmission control protocol, which is used in transport layer. And now we are not always working with the connection oriented system, so definitely there is a need to do our communication with wireless devices. For wireless devices sake, they have introduced one more protocol called UDP, Uniform Data Transfer. In this UDP protocol, what they are trying to do is, we call it as unreliable protocol because it works on wireless, and data may transfer in different directions. So unreliable protocol, UDP is an unreliable protocol. Basically it is used for wireless data communication. And then the major issue of this entire networking model is routing. Now that routing protocol, we call it as a network layer in TCP/IP. It make use of a protocol, as I already told you, IP. IP means Internet Protocol. How all these systems are recognized in the world means, all systems are recognized with the help of a identity schema called Internet address, IP. Internet address. So now IP is the one of the protocol which is implemented by this network layer in TCP/IP model, and along with this IP, they make use of ICMP and IGMP protocols, which we call it as a control which are used for exchanging the control information, like if you want to check out the connection, whether connection is established or not, and acknowledgement is coming or not. You want to check whether the system is connected to you or not with the help of ping messages, or you want to know the status of the line, whether it is busy, or how much bandwidth is now in use. All these things you can do with the help of such kind of protocols called ICMP control protocols, internet control protocols. And there is one more called grouping. When a message has to be delivered to a group, broadcasting or multicasting, such kind of activities are controlled by, like if you want to send a message to a group of people, or you want to send a message to particular group in the entire network. Likewise, if you want to do grouping related activities, if you want to make a membership of the group or if you want to go out of the group, likewise all grouping related activities are taken care by a method called IGMP, which is again deployed in network protocol. So these all will add more and more functionality to the networking protocol, networking layer. So ICMP, IGMP, IP is a base anyway. IP is a base for all these activities, and even you can make use of RARP and ARP, address resolution protocol, reverse address resolution protocol. These protocols are used to identify the best path in the destination flow. Like if you want to reach the destination, in which you are going to get a best path, and these two protocols are specifically dedicated for converting the addresses. For example, if I am in local system, which address I know is, I know physical address. If I am talking with a global address, if I am talking with a global system or a remote system, we never know the physical address of that device. So now what happens means, there should be a mechanism to convert one address into another. Like if you know the logical address, we want to get a physical address. If you know the physical address, we want to get the logical address. Likewise, if you know these two, then only this packet is added with this header information. So generally network layer adds IP addresses, MAC will add data link layer will add physical addresses. And if you know one address, how do we get another address? Likewise, in order to do this kind of translations, we make use of address resolution protocol, that we call it as ARP, and one more is reverse address resolution protocol. So if you want to get it from logical to physical, physical to logical, then you can make use of these two protocols. So these are the different protocols we can deploy inside network layer in order to get more and more functionalities. So This is about one more layer in TCP/IP, that is network layer, which we call it as, in general, we call it as the internet layer, or it also known as network layer. And coming to this one, data link layer. So data link layer functionalities, physical layer functionalities are collectively implemented in TCP. Like it is called as host to network layer. Generally, these two combinedly called as host to network layer, where it make use of all the functionalities which are related to data link layer and physical layer. So these are the functionality distribution in different layers of TCP/IP model. So coming to this presentation layer, that we application layer itself includes presentation and session. So these protocols are responsible for how the data is compressed and how the data is translated, and how this security related issues are added, like which kind of encryption techniques they have adapted. All these things are part of this application layer protocols. This way, these two layers are not directly included in TCP/IP model. Those are already part of the protocols. That's it. So in this way, TCP/IP model consisting of majorly four, and if you want to read it like TCP/IP model, it consisting of physical layer, data link layer, network layer, transport layer, and application layer. Presentation session are skipped, but functionalities are not skipped. So this way, TCP/IP model is existed in comparison with the OSI model, which is a basic reference model for any kind of networking. Okay, so next slide. In next slide, we will talk about see this one. Okay, how addressing is done. So there are different kind of addressing existed when you want to refer to an application, or when you want to refer to a system. Generally, as a user, we always talking with the applications. So now we never know IP addresses, or we never know MAC addresses in our data communication. When I'm doing communication, I don't know what is your IP address, what is your logical address. All these things I don't know. What I know is a special address called as WhatsApp. Like I have a website address. I typed in, and I get into the contacts, and then I try to push a message onto your system. This way we as a general user doing, but internally there are different kinds of addresses are existed in order to identify a device, identify a application. So in TCP they make use of four kind of addresses. Physical, in any model it is existed, the types of addresses are physical address, logical address, port address, and specific address. So let us talk about this one in detail. So now if you talk about physical address means every hardware device we take, it should have some unique identity which is not existed with others. That unique identity will give you who is manufacturer, manufacturer code is there, product code is there. Likewise, by looking into that unique address itself, we can say it is coming. For example, if you take laptops or if you take desktops, the pre-code of that MAC address will give you the manufacturer. If it is having some XYZ belongs to Dell, if it is ABC belongs to some other company. Likewise, manufacturer address also included inside that physical address. So this way, physical addresses are assigned to any device. It is inbuilt, never changed. It is never changed. If there is a system, it should have permanent address, that we call it as a physical address. But when you talk about this one, logical addresses are used to create your own network. Logical addresses are used to create your own network, and you can make use of any kind of number IP addresses. For example, I have 100 systems. I want to create a group of 25. Then I can assign these are the logical addresses. I want to give it to one group, and this can I can give it to one more group. Likewise, I decide which IP address may be assigned to which system. It is changeable. Like now I use one IP address for one system. Later I want to remove it. Then I can remove it and I can give it to some other system. So IP addresses are temporary addresses which are identified in the network. Very simple. Which are used to identify the device in the network, and later IP addresses can be modifiable. There are many kinds of IP addresses which are modifiable, which are not. We will see in depth when we talk about network layer. And there exists one more address called port address. This one, port address. In case of port address, as I already told you, when a system is existed, there are multiple applications running on it. Every application should have an identity. So knowing the system address never helpful for us. Knowing the application address on the system is helpful. Okay, knowing college address is not enough without knowing your classroom. Very simple. Knowing college address is not enough without knowing our classroom. Similarly, when you identify a device to make some kind of data transfer, again we need to identify to which application our data has to be delivered. That is called as a port number. Every application we take in the system, all are running on different port numbers. So if you give some port number automatically, so it is coming from HTTP protocol, or it is coming from FTP, it is coming from SMTP. Likewise, all the protocols are given with some kind of addresses. That way port addresses are helpful in order to identify the application addresses. Now, finally, there exists a specific address category. Nowadays, we as a user never bother about addresses like physical address, logical address, even port number. We don't know on which port our WhatsApp is running, on which port our Facebook is running. All these things we don't know. What we know is web address, that you call it as URL. www.facebook.com, gmail.com. These we call it as a special addresses. But these special addresses never works in internet. But there is a lot of process behind it. When that address is typed in the browser, it goes to a server called DNS. In DNS, what happens means all textual related addresses are converted into numbers. Gmail.com. So where gmail.com application is existed, which IP address is existed for this Gmail, and on which port number this Gmail is running, all these things are taken care by this server called as DNS server. Likewise, the addresses used in TCP IP model are 4 types: logical address, physical address, and then port address and specific address. So these are the different IP addresses we use. Okay, now at specific to the applications or layers, on which layer which addresses are used, that we can easily identify now. So if you see this one, application layer. In application layer, we always make use of specific addresses, like because Facebook, WhatsApp, all these things are applications. We are going to refer those applications with the help of names. That's the reason application layer is always worry about what the addresses used at application layer is specific addresses. And when you talk about this one, transport layer, once the data is taken out and merged, and to which application this data has to be delivered is taken care by transport layer. Process to process delivery model is used by process model, transport layer. So that transport layer making use of these port addresses. And now when you talk about network layer, as we already know, logical addresses of the systems are identified at a network layer. So logical addresses are used. And when you want to identify the physical address, then they make use of data link layer. So addresses used, or these are the addresses, like specific, and then after port address, and then after logical address, then after physical address. These are the corresponding places where these addresses are useful. Okay, and up to this point we have completed layers which are existed in TCP in comparison with the OSI model, and what are the different addresses we use in TCP, and where those addresses are existed in the layered architecture. Okay, we stop this class up to this point.